All right, so you can see here, we're going to go ahead and test these. I'm going to show you how to figure out if a solenoid is bad or good. And so we got two solenoids here. I actually took these off of a golf cart, so I know that one of these, something about one of these isn't good. So reverse wasn't working on this setup. And what happens with these setups is instead of the manual reverse switches that you see on some golf carts, it uses a set of these solenoids to change the polarity of the fields on a series motor. And so what happens is these things just wear out internally, and we'll take this apart and figure out, and we'll look internally why these go bad in this video. But I'm going to show you how to troubleshoot which ones are bad and which connection is bad. So I'm going to just put it up here. You can see we got our power supply first and foremost here. This is going to be what we use to turn the solenoid on. So we're going to hook the negative to one side and the positive to one side. And you say, well, which side is which? Doesn't matter. Okay. It's just an electromagnet in there, and the polarity does not matter. This is not an electronic. Okay, there's no polarity sensitive electronics in there. It does not matter which side is which when you're doing it this way. So you'll hear the click. Okay, so that's what happens there. And we're going to leave that one off for now. And I'm going to show you, zoom in a little bit here so you can see these better. We got our meter, and you're going to need this for continuity. So you're going to switch your meter to the point where you got the continuity meter here. So what happens is when you touch your probes, your meter beeps, and it also gives you a resistance reading. But you can see on this, on these solenoids, what happens is when it's not on, it's touching one side, and when you turn it on, it clicks and it touches the other side. So I'll actually have continuity on this side across these poles because this one's touching right now. All right, so it should be the same on this one. I have continuity across there. Now, if I turn this one on, what happens is I get continuity now across here, across these ones. So I got continuity there, and we're going to switch over to this one. And see what we got. So we have continuity there. Now, what you'll notice with these is we may have continuity, but we were definitely having reverse problems with this. And so one of these, I may be getting a little bit of continuity, but it's not enough to get a golf cart going. And so when the golf cart tries to go, arcing happens a little more, makes the connection worse, and then it can't go. But with this little meter, I may be actually getting a continuity reading. So we're going to go ahead and disassemble these and show you how they go bad internally and see how bad these truly are inside. All right, so here's the solenoids taken apart, and you can see on this side we have little connectors. This obviously moves back and forth with the electromagnet that's in there. You can see the windings in there. So that just helps that move back and forth, and then it makes contact here. So that's kind of how that works. And you can see how those connections are pretty good. But then when we come over to here, these connections are pretty bad. Not horrible, but they are bad, and any roughness of it is poor connection. They should be smooth like that. So smooth and smooth. If it's a rough surface, it's not going to be a good connection because there's a bunch of air gaps in there. So the same situation here. So you can see This is probably the side it rested on all the time, and then when they were engaged, they would flip and make connection. And so this one you can see is even worse. This was probably the main culprit, and the same there. And then this side is nice and buttery smooth with a couple little faults there. So you can see kind of how that can happen as those connections get worse and worse. Hope this helps you understand how these things go bad.